Here's my global data script and all the public variables that are in it. And really, that's all this script does. It just captures all these public variables. I can put the values here in the inspector. When I then run the app, it copies these values into a static global data class, essentially. So, and being that all these that makes all these static variables then globally available to every script. So I have things in here that are specific to plants, specific to fish, and those scripts will look at this for like parameter type values, which I might want to tweak as I'm kind of designing the thing and editing it. So you'll see the list is quite long and it keeps growing. Obviously, I think I've maybe shown these actually some before. I do have this plant seconds between growth, so it's every 3 seconds then the plant will grow to the next size up. I don't know if that's too fast or too slow yet, not sure. Got a little bit of variance in that growth speed. If a fish takes a bite of a plant, then that plant will shrink in size, but will still be able to start growing again because this is not totally dead. But it won't start growing for 5 seconds. It's kind of in shock, I guess, from being bitten, having a hunk bitten out of it. Max plant size right now I've set to 8, but the variance on that of 1, so it could grow to 7 and stop, or it could grow to 9 and stop. Mature plant size is 4, so when the plant gets to the size 4, then it can sprout a secondary plant growing off of it. But that plant will also then keep growing until it gets to be 8. Here I've set things like what I want the world to look like. I've got 50 fish, 75 plants are being spawned when I start the app, 50 fish. But I also have a maximum number of plants of 750. I'm sure I'll need to add a max number of fish at some point too, perhaps, once they start laying eggs and breeding. Plant size scaler, I don't even think I'm using that one anymore. Animation for the tail. The maximum turning angle is 0.5 degrees per fixed update. So I'm not sure what that equates to in time really, but the initial for the fish sizes, now they have variable sizes. So the smallest it can be is 0.25, and the biggest fish will be 3. And then I also have the min and max of a fish length ratio. So if the length ratio is 1, then it's a normal looking fish. If it's less than 1, it's a little bit of a squatty fish, and if it's bigger than 1, then we get a longer fish, all the way up to having a ratio of 2. Right now I've got my fish thrust set to 0.06. That's just kind of the amount it can accelerate, and it will keep accelerating in the direction the fish is pointing until it reaches the max velocity, which right now is set to 2. I've just recently implemented this stuff regarding energy. So when a fish takes a bite out of a plant, it receives some energy from that, and a bigger fish takes bigger bites and therefore gets more energy out of each bite. But a bigger fish also uses more energy just to stay alive and to swim. So kind of a trade-off there. Seconds between decreasing energy. So this is when I just say every 1 second it's going to decrement the energy in the fish based on their speed that they're swimming and based on the fact that they're just alive. And I've got some constants here some scalars that I've got in there based on the so energy use per mass. So I end up to decide how much I'm going to decrease. I'm going to decrease just for being alive the mass of the fish times this scalar here of 0.01. And I'm also detracting for the speed of the fish, I'm taking the mass of the fish times this scalar times the velocity of the fish is traveling. So by putting them in here, I can kind of tweak the numbers and see what kind of makes sense and what works best. The max energy a fish can have in itself is 50, but I think that's not exactly true. That's kind of the base number, 50. But if it's a smaller fish or a larger fish, that number will scale up. So if the length ratio is set to 1, and if the width of the fish, the size of the fish, is also set to 1, then the max energy would be 50. But anything bigger or smaller, that number's going to be scaled up and down a little bit. Makes sense, because a bigger fish could contain more energy inside itself, and a smaller fish would have less energy reserves. Seconds between each bite. So that just talks how fast a fish can take a bite when it's over top of a leaf. And the size of each bite is 0.25. That's just kind of a scalar number. And like I said, that number multiplied times the size of the mouth of the fish is how big of a bite it takes. All right, so I've implemented. Also, if a fish then runs out of energy, it's going to die. So I think in this demo, you'll see, especially the bigger fish are more likely at this point to die because they run out of energy so quickly. So if you see a fish disappear at this point, it's because it ran out of energy. Obviously, there's not many plants yet either, is kind of the problem. And the big fish go through energy more quickly. So, oh, there goes that big one there. I'm going to follow another one of these big guys here in the center of the screen. And we'll see if he dies off or not. So, with all those parameters that I have in the system now the real challenge becomes what makes sense. What are good numbers to use? And tweaking those parameters to make for the best, kind of most realistic, I guess, kind of environment here. How do I balance the number of fish versus the number of plants? How do I balance the speed the plants grow versus the number of fish and how fast eventually they're going to reproduce? All those sorts of things. So that's going to be a challenge. I'm also going to have fish eventually be able to like bite into other fish. And I also want to implement having the fish be different colors. So I think the colors might be coming kind of soon. But this guy's doing pretty good. He's still alive. Here you can see we have a real fat, stubby fish. Whatever I click on, it'll follow it around. And the longer fish can go faster. I forgot to say that as well. So there's longer, faster and sleeker. There's a little tiny fish right there. I also need to implement that the fish are going to grow. So a tiny fish like that will be when it comes out of an egg, it'll be that small. And then we'll slowly grow to the max size of the fish. I guess it should take more energy as it's growing. Maybe once it's full grown, it might be a little less energy than while it's in growth mode. So that's where we stand so far. Very excited to show my fish now that are now colorful instead of that bright Pac-Man yellow. Now they can be all different colors. So when they spawn, they pick a random color between 0 and 1, which is all the range of hues, and then it assigns it to every sprite renderer that makes up each part of the fish's body. So I think it looks kind of cool. And the idea here is that eventually, hopefully, the color of things will give us some indication of some of the genetic pairings that end up between the different fish, and so their children will be kind of a mix of their colors or something, and you'll get some idea of the genetics drift based on the color of the fish. That should be helpful. I've also added fins, and so you'll notice if a fish turns to the left, his left fin will come out some, and if he turns to the right, his right fin will come out to make him turn to the right. So I think it looks kind of neat. I might need to increase the amount the fins come out to exaggerate them a little more, because it's a little bit it's subtle right now. And also you'll notice that the fish, especially the big fish, a lot of them have already died off already. They just don't get enough energy from enough plants given this level of foliage. So something to think about. I might need to have more plants if I want my big fish to stay alive longer. Up to this point, I've been working under the assumption that longer or bigger fish somehow have a higher max speed than a smaller fish. But in thinking about wanting my fish to look like kind of like real fish when they swim, in terms of like the speed of their tail moving, how fast they're traveling, and what their maximum speed might be based on how big or small they are, I decided to look it up on Google and found this article called "The Speed of Swimming of Fish as Related to Size and to the Frequency and Amplitude of the Tail Beat." And it's found in the Journal of Experimental Biology, Volume 35, Issue 1, from March of 1958. Could not believe such an old article. There's a link to the PDF right there. So anyway, there's our article by Richard Bainbridge. He sent this paper into the journal June 14th, 1957. They published it in like March of 1958. So, like, wow, that goes back a ways. So, I looked through that. I skimmed it mostly. And he looked at 3 different fish of different sizes and put them in some kind of a contraption where the fish would swim in a circle, I guess, and he would time how fast they could swim, and measured their speed, their lengths, and their and how fast they would beat their tails, and plot them on these graphs. Digging through all that, let's skip to the conclusions. Got some good information from the conclusions. Let's see, where's the first piece? Right here. Found a nice simple equation, pretty simple, for the velocity of a fish. We'll go with this equation. These are 2 ways to write 2 different equations. So the velocity of a fish equals 1/4 times the length of the fish times 3 times the frequency of the fish's tail is beating in beats per second minus 4. So a nice simple equation there. So obviously if the length increases, the velocity increases. But another key variable is this frequency part. And down below here it even says, in calculating possible maximum speeds, the upper limit of frequency remains the controlling factor. So if a fish can't beat his tail very fast, he's not going to go nearly as fast even if he's long. So he compared that to a lot of other fish speeds in the different journals and things to see how well his equation matched, and matched pretty well. This was, I thought, really interesting. When it talks about the maximum, each beat of the tail at its maximum amplitude. In other words, how when the tail is moving as far to the right and left as it can, as that fish is swimming. So really hard beats of the tail. And what was interesting, for all these different kinds of fish that he looked at, the distance traveled per beat was very comparable when the tail was beating its full amplitude. Basically 0.6 times the length of the fish. Very consistent. And here it talks more about some of how the frequency might change. Like for the trout, 17 beats per second at 30 centimeters, but for a 60 centimeter trout it goes down to 15 beats per second, 14 beats per second for 100 centimeter trout. At least those are his estimates there based on the smaller fish that he looked at. And then from his summaries right there, I ended up coming up with these kind of results. First of all, come on, wait till it gets larger here. The speed is directly proportional to the length of the fish. So indeed, longer fish can swim faster. And there's the velocity equation that's given. I might try to incorporate that into my simulation if I can. Maximum tail amplitude. Okay. Not as important, but interesting. It's pretty consistent between the different fish. And the maximum frequency that the fish can beat its tail decreases a little bit as the fish gets much bigger. The average distance traveled equals this per beat of a tail is essentially 0.6 the length of the fish. So roughly speaking, I think I'm going to use this information. I'm going to use a frequency of 10 beats per second as kind of an average for an average size fish. And then I could use that equation there. So it was surprised that I was able to find an article so closely related to this, find it as easily as I did. It was the first hit that came up on Google, and that it's even comes with some really useful equations like the velocity equation, where it's really spelled out for me. So putting that into the code will be a piece of cake, I think. So I just wanted to share that with you. Otherwise, I haven't done much research on this project, honestly. Researched Unity and how to program it, but not really researched fish per se. I'm far from a fish expert.